Hello everyone and welcome to this week's video. Today I'm going to be explaining electric motors in their most basic form, which is DC motors or direct current motors. Now, to understand motors, the most basic principle you need to understand is the left-hand motor rule, which basically says if you have a magnetic field flowing from north to south in this direction and a current flowing from positive to negative in this direction, then you're going to have a force on whatever that current is flowing through in this direction. So you can just use your left hand to figure that one out. You've got your magnetic field, your current, and your force. Okay, so here we've just got a very basic visualization of that. So we've got our magnetic field going from north to south in that direction. We've got our current flowing from positive to negative. We've got a battery here, and so that's going to be flowing in this direction. So the force on this wire is going to be up. Okay. So now let's make it a little more complicated and throw it inside of a rotating system. So what we've got going on here is we've got this axle, and on this axle there is a wire going around, and the wire is connected to two commutators, one on each side. And so the important thing to note here is that these brown commutators here, which are a little copper contact point, are connected to this axle, and this axle is non-conductive, whereas these commutators are conductive, so current can pass through them. So all of this rotates as one, and then these brushes and wires here do not rotate, they stay where they are, they're stationary. So what we've got going on is, here's the plus side of your battery and the negative side, you've got your current flowing through the wire, and then you've got your magnetic field north to south. So just like here, we've got our magnetic field. We can take a look at this wire right here. We've got our magnetic field going from here to here. We've got our current flowing across like that, and so our left-hand rule is going to tell us that that wire is going to go up. Now on the other side of this, we've got the current flowing in the opposite direction. So instead of the force going up, the force is going to push that side of the wire down. So what you've got here is this rotating axle, which is on a bearing, and so this is going to start to push it around and rotate this axle, hence creating a motor. You've got a revolution going on. So what happens is these commutators, as this wire switches over to the other side, and the commutators are also rotating with it, but the brushes aren't, the current is going to switch. And so I've got it zoomed in a little bit here so that it's a little more clear as far as what's going on there. But basically, once this side of the wire gets over here, the current is no longer going to be flowing this direction, it's going to be flowing that direction. So once it's over here, it'll look just like it is depicted here. So it's a direct current. The current is never changing direction, but the wire is switching which way it allows it to travel on because of this commutator. So it's separated here, the two different commutators. And so that allows this to continually spin, and hence you have created a motor. So how do you get a greater force there? What I've drawn in green? Well, you can have a stronger current go through, so a stronger energy supply from battery. You could have stronger magnets, or you could have multiple wires. And if you have more wires, each one you're going to kind of multiply that effect of that force on it. So just to get a little bit better idea of what this commutator looks like, you can see the copper piece right there. So that's the basics of how motors work. I'm going to have some more videos explaining in a bit more detail, but for now, if you have any questions or comments, feel free to leave them below.